x plus 2 is equal to 80. So what is the value of x? Solution. So we have 5 raised to power x plus 2. This is equal to 80. Okay. So 5 raised to power x plus 2 is in the form of a raised to power n plus m, which we can express as a raised to power n multiplied by a raised to power m. Alright, so let's do that, so that you're going to have 5 raised to power x multiplied by 5 squared. This is equal to 80. Okay, so 5 squared, this is equal to 25. Alright, so we're going to have 5 raised to power x multiplying by 25. This is equal to 80. Okay, so we divide both signs by 25. Both signs by 25. All right, so that's 5 raised to power x. This is equal to, we divide both signs by 5. So if you say 80 divided by 5, this is 16. And if you say 25 divided by 5 is 5. So this is 5 raised to power x. This is equal to 16 divided by 5. How do we solve for the value of x? We introduce the natural logarithm, so that we're going to have log 5 raised to power x. This is equal to log 16 divided by 5. Okay, so now from here we introduce the logarithm power rule, so that if you have log m raised to power p, this can be expressed as p log m. All right, so you'll have x log 5. This is equal to log 16 divided by 5. Okay, and again, if we have log a multiplied by b, this can be expressed as log a plus, we have x log 5 is equal to log 16 divided by 5. Okay, so if you have log a divided by b, we can express this as log a subtract log b. So let's apply this identity, so that you're going to have x log 5. This can be expressed as log 16 subtract log 5, divide everything by log 5, log 5, log 5, so that the value of x is equal to, now if you simplify, you're going to have log 16 divided by log 5 subtract 1. Okay, subtract 1. Now as you can see, log 16 divided by log 5 is in the form of log a divided by log b, which can be expressed as log a to base b. All right, so now we're going to have x is equal to log 16 to base 5 subtract what? Subtract 1. Now this is the value of x. Okay, this is our value of x. That is our value of x. And let's verify, let us verify if this value of x satisfies the equation. Now as you recall, we end that 5 raised to power x plus 2, this is supposed to give us a value of 80. Okay, so we substitute the value of x back to our equation, so that we're going to have log 16 to base 5 subtract 1 plus 2. This is equal to 80. It's supposed to give us a value of 80. Okay, now as you can see, this is 5 raised to power log 16 to base 5. Now this is negative 1 plus 2. This is plus 1 is supposed to give us a value of 80. Okay, now as you can see, 5 raised to power log 16 to base 5 plus 1 is in the form of a raised to power n plus m, which you can express as a raised to power n multiplying by a raised to power m. Okay, so let's apply that, so that now we're going to have 5 raised, that is raised to power 16, log 16 to base 5 multiplied by 5 raised to power 1. This is supposed to give us a value of 80. Okay, saying that 5 raised to power log 16 to base 5 plus 1, which is supposed to give us a value of 80, is in the form of a raised to power n plus m, which we can express as a raised to power n multiplied by a raised to power m. Okay, this is how we do. We'll have 5 raised to power log 16 to base 5 multiplied by 5 raised to power 1. This is supposed to give us a value of 80. Okay, but now if you have m raised to power log a to base m, this essentially is supposed to give us a value of a. Okay, so now if you have 5 raised to power log 16 to base 5, this is supposed to give us a value of 16. Now we substitute 16 back to equation, so that you're going to have 16 multiplied by 5. This is supposed to give us a value of 80. And as you can see, 16 times 5, this is 80, which is equal to 80. Okay, and that shows that the value of x, which is equal to log 16 to base 5 subtract 1, satisfies the exponential equation. So thank you for watching, and kindly subscribe.